Have you ever wondered why bread races? Or why cakes are soft? Or why cookies are crunchy? Though all three of them uses the same ingredients? The answer lies in the fascinating world of bakery technology, a perfect mix of art and science. In this video, we will uncover the secret science behind baking, how ingredients like flour, sugar, fat, eggs, and yeast work together, and what happens inside the oven. Let's get started. Before that, we will look into the essential and non essential ingredients of baking. Essential ingredients are those that are absolutely necessary to produce a baked product. Without them, the product cannot be formed. These include flour, water, yeast, and salt. Non essential ingredients are optional ingredients that are not required for making a basic baked product, but they improve quality, flavor, texture, and shelf life. These include sugar, fat, egg, and flavorings. Our first ingredient will be flour. Do you think flour naturally has gluten in it? The answer is no. What it actually contains are two separate proteins, glutenin and gliadin. When we add water and pressure, the proteins interact to form gluten. Gluten is a unique protein network that has two key properties, extensibility and elasticity. The viscoelastic balance gives a workable dough. Extensibility provided by gliadin allows the dough to stretch. Elasticity provided by glutenin allows the dough to spring back. During fermentation, the gluten network traps the carbon dioxide gas produced by yeast, allowing the dough to expand. In the oven, heat causes the gluten proteins to coagulate, setting the final structure of the bread. To see gluten in action, here is a simple demonstration. Knead flour and water into dough, then wash it under running water. The starch washes away and what remains is a sticky rubbery mass. This is gluten. Stretch it and you can see its elasticity. When we think about flour, most of us focus on gluten proteins, but in fact, about 70 to 75% of wheat flour is made up of starch, and it plays a very important role in baking. Though gluten takes all the credits, starch are the real unsung heroes. Starch is the primary food source for yeast. During fermentation, enzymes like amylase break down starch into simple sugars, which yeast converts into carbon dioxide and alcohol. Without this sugar supply, fermentation would not continue efficiently. Sugars are digested by the yeast and respires anaerobically, which results in a small CO2 bubbles in the dough. Upon placing in the oven and baking, this leads to a fluffy bread. Let's talk about role of starch in the texture. Upon mixing and initial stages of heating, the starch granules absorb water and start swelling. This is the point where gelatinization begins. The mixture thickens as the granule takes in more water and expands. With further heating, the mixture reaches its maximum viscosity. The starch network is fully swollen, and with continuous heating, granules break down, and the complete gelatinization occurs at 120 degrees Celsius. And the last stage, upon cooling of the product, the starch molecules start reassociating themselves. This process is called retrogradation, and this leads to a firming of the product, and with time, stalling or aging occurs. Sugar involved in two fascinating reactions, Maillard reaction and caramelization. Let's talk about them in detail. At 310 degree Fahrenheit, Maillard reaction begins. Proteins and sugars react with each other through a series of chemical reactions and use malanoidins, and this give a characteristic brown pigments to our foods. They are also responsible for a characteristic golden brown color in our cookies. Apart from the color, they also impart a nutty and an array of aromatic compounds in our cookies. Next, we do have caramelization. When the sugar is heated at too high temperature, it undergoes caramelization, a process where sugar molecules break down and form complex compound that gives a golden brown color. In simple words, caramelization is just the burnt sugar that tastes better, and Maillard reaction is the reaction between proteins and sugar, and together they give a tasty brown stuff. Let's move to the another essential ingredient in bakery science, fat. One of the most important techniques where fat plays a key role is the creaming method. In this method, usually butter or margarine is beaten together with sugar. As you mix the sugar, crystals cut into the fat and trap tiny air bubbles. These air bubbles expand during baking and help cakes and cookies rise and giving them a light and tender texture. When fat is added to the dough, it coats the flour proteins. This prevents the complete gluten network formation and results in a soft, more tender crumb. Butter is a natural fat from milk, rich in flavor, used in cakes, cookies, pastries, and laminated doughs. It provides tenderness, flavor, and contributes to aeration when creamed with sugar. Secondly, we have shortening, a type of solid flavorless fat usually made from vegetable oils. It is excellent for tenderizing baked goods by coating flour proteins, limiting gluten formation, and creating flaky textures in cookies, pie crusts, and pastries. Third, we have margarine, similar to butter but made from vegetable oils. It is often used as a substitute for butter in cakes and pastries, provides structure, tenderness, and moisture retention. Oils. They are liquid fats used in quick breads, muffins, and cakes. They improve moisture and shelf life and create soft and more tender crumbs compared to solid fats. Salt is a small but essential ingredient in baking. Although it is not involved in structure like flour or fat, it plays several important roles. Flavor enhancer. Salt balances sweetness and enhances the overall flavor of baked goods, making the taste more rounded and appealing. Gluten strengthening. Salt tightens the gluten network in dough, improving elasticity and giving bread a better structure and chewiness. Yeast activity regulation. Salt slows down yeast fermentation, preventing overproofing and ensuring a controlled rise. Crust color and browning. By affecting sugar solubility and dough moisture, salt can influence the color and texture of the crust. In short, even though it is used in small amounts, salt contributes to taste, texture, and dough stability. Eggs. Eggs are non essential ingredients in baking. They contain two important edible parts, the white, also called as albumen, and the yolk. The egg white is made up of mostly of water and protein. It does not have any fat, and that makes it very useful in baking. When we whip egg whites, the protein stretch and trap air, forming a foam. This foam gives lightness and volume to products like meringues, souffles, and sponge cake. On baking, the proteins coagulate and set, giving the structure and firmness. Egg whites also act as a natural binder, helping ingredients stick together, and they can give a crisp texture in products like macaroons. The egg yolks, on the other hand, is richer. It contains fat, proteins, water, and special components called lecithin, which is a natural emulsifier. This means yolks can blend oil and water together, gives us a smooth batter, and prevents separation. Yolk adds richness, flavor, and golden color to cakes and pastries. The fat in yolk tenderizes the product, keeping it soft and moist. When heated, yolk proteins thicken and set, which is why yolks are essential in custards, creams, and sauces. Leavening agents are substances that help bake products rise and become light, soft, and porous. In simple words, they create air or gas inside the dough or batter. When heat is applied during baking, these gases expand and making the product fluffy instead of dense. There are three types of leavening agent based on their nature: physical, chemical, and biological. Yeast falls under a biological leavening agent, more specifically, a single-celled fungus. The common species used in baking is Saccharomyces cerevisiae. When yeast is mixed into dough, it feeds on sugar present, either the natural sugars from the flour or added sugars. Through a process called fermentation, yeast breaks down the sugar and produces two main byproducts, carbon dioxide and alcohol. The carbon dioxide gets trapped inside the gluten network of the dough. As the dough rests and proofs, these gas bubbles expand, causing the dough to rise and give bread its soft, spongy texture. The alcohol produced during fermentation mostly evaporates during baking, but it contributes to unique flavor and aroma of the bread. The common types of yeasts are cream yeast, compressed yeast, active dry yeast, instant dry yeast. First, let's look into the dry yeast. Dry yeast or granulated form, which needs to be dissolved in warm water around 40 to 44 degrees Celsius along with sugar to activate them. Over time, the yeast mixture will form a froth that can be mixed with the dough. Secondly, we do have cream yeast. Cream yeast is essentially a yeast in liquid suspension form. It contains about 15 to 20% solids and is stored and transported in refrigerated tanks. Cream yeast is mainly used in large scale commercial bakeries because it allows easy pumping and automatic dosing into dough mixers. It is highly active and fresh, but since it has a very short shelf life, it is not practical for small bakeries or home baking. Fresh or compressed yeast are moist, perishable, and are often used by professional bakers. We also have instant dry yeast. They are finer granules that can be mixed directly into the flour, faster acting than dry yeast. They need not be activated by warm water or sugar before their usage. Chemical leavening agents are substances that release carbon dioxide gas through simple chemical reactions. Unlike biological agents like yeast, which needs time for fermentation, chemical leavening gives an almost instant result. That is why they are called quick leavening agents. Baking soda is the pure chemical compound sodium bicarbonate. On its own, it won't release gas unless it reacts with an acid. When baking soda is mixed with acidic ingredients such as lemon juice, vinegar, buttermilk, honey, or even cocoa, it reacts and produces carbon dioxide. This gas expands in the oven heat, giving lift to cakes, cookies, and pancakes. However, if too much baking soda is used or if there isn't enough acid to balance it, the product can have a soapy taste and yellowish color. Baking powder is more balanced product. It contains both sodium bicarbonate, the base, and a powdered acid. The powdered acid can be cream of tartar along with starch to keep it dry and stable. Because it already has acid inside, it just needs moisture and heat to work. Despite baking soda and baking powder being more popular, ammonium bicarbonate is also an important leavening agent. Upon heating, it breaks down into carbon dioxide, ammonia, and water vapor. Since all three of them are gases, there is no residue left behind. This makes it excellent for low moisture thin products like cookies, crackers, and biscuits, where it gives a crispy and light texture. But in moist or thick products like cakes and breads, the ammonia gas may not escape fully and leaving an unpleasant smell. That is why it is mainly limited to dry baked goods. In short, ammonium bicarbonate is perfect for crispy items but not for soft and moist products. Physical leavening agents are not chemicals or microbes. Instead, they rely on air and steam to make baked products rise. Air gets incorporated during mixing, beating, or whipping. For example, when we cream butter and sugar or whip egg whites, tiny air bubbles are trapped in the batter. These bubbles expand in oven heat, giving lightness to cakes, meringues, and souffles. Steam is another powerful natural leavening agent. Water in the dough or batter turns into steam when heated, and since steam occupies as much as larger volume than liquid water, it pushes the product upward. Steam is the main leavening force in products like puff pastry and eclairs. So, when we look at all these ingredients together flour, sugar, fats, eggs, salt, and other different leavening agents we realize that baking is really a science of balance. Flour gives the structure, sugar adds the sweetness and helps with browning. Fat makes products soft and tender, and eggs brings both structure and richness. Salt sharpens the flavor and strengthens the dough, while leavening agents, whether biological, chemical, or physical, create the rise and lightness that turn a dense dough into a fluffy cake or bread. Each ingredient has its own role, but the magic of baking happens when they all come together in right proportions. That is what transforms simple raw materials into soft breads, rich pastries, and delicate cakes we enjoy. Baker's percentage is a system for expressing recipe ingredients as a percentage for total flour weight, where the flour is always 100%. This allows bakers to easily scale recipes, adjust ingredient ratios, compare formulas, and communicate using a common language. To use it, divide the weight of any ingredient by the weight of the flour and multiply by 100 to get baker's percentage. To calculate the weight of the ingredients from the baker's percentage, multiply the percentage with the weight of the flour to obtain the weight. For example, here the 70% of water is multiplied with 500 gram of flour to get the actual weight of water to be measured. which is 350 grams. Thank you.